Hi, this is Jeff West, and I would like to give you an overview of the WebLogic ClassLoader hierarchy, the filtering ClassLoader, and then show you a demo of the new ClassLoader analysis tool that's available in 10.3.4. Here's an agenda for the session. First, we'll take a look at WebLogic's ClassLoaders. Then I'll give you a brief introduction of the ClassLoader analysis tool before we do a live demo. There are several levels of ClassLoaders used in WebLogic. Obviously, there's a top-level class loader that loads the WebLogic implementation classes and supporting libraries defined in the Classpath, including those added to the setDomain-env and COM-env scripts. This is called the system class loader. The next level of class loader is at the domain level. This class loader is a child to the system class loader and loads libraries that are included in the domain/lib directory. Generally speaking, WebLogic Server class loading is centered on the concept of domains and applications. An application is normally packaged as an enterprise archive or EAR file containing application classes. Everything within an EAR file is considered part of the same application. If you deploy an EJB and a web application separately, they're considered two different applications. WebLogic Server automatically creates a hierarchy of class loaders when the application is deployed. The root class loader in this hierarchy is the application class loader, and it loads modules defined in the application, including EJBs, as well as Java EE shared libraries and libraries included on the configured library directory path for the application. A child class loader is created for each web application or WAR file and loads the shared Java EE libraries as well as the libraries and compiled classes in the WEB-INF folder. So why did we do this? It's common for web applications to call EJBs, and the WebLogic Server Application Class Loader architecture allows for JSPs and servlets to see the EJB interfaces in their parent class loader. This allows for EJBs to be called by reference for higher performance, and it also allows web applications to be redeployed without redeploying the EJB tier. If you deployed the WAR and JAR files separately, WebLogic Server creates sibling class loaders for them. This means that you have to do some additional work to have your JSPs and servlets hit your EJBs. However, this changes a bit with EE6 since you can package EJBs in WAR files, which is a much needed feature that I'm looking forward to. Keep in mind though that the web application class loader contains all classes for the web application except the JSP classes. The JSP classes obtain their own class loader, which is a child of the web application class loader, and this allows JSPs to be individually reloaded. WebLogic offers a feature called the filtering ClassLoader, which overrides the top-down class loading behavior of the default system and essentially enables child-first class loading. When filtering is enabled, the resources from the child of the filtering class loader, which is an application class loader, down to the calling class loader are returned before the ones from the system class loader. What this allows you to do is specify a set of Java packages that should always be loaded from the application, not the system class loader. The system class loader loads the libraries that are included with WebLogic, so if you want to override a version of the library included with WebLogic and included in your WAR or EAR file, you can use the filtering class loader to do that. Some common examples of this are Antler, Xerces, and some other XML tools that already have versions included in WebLogic. It is also possible to use this in order to deploy a newer version of JAX-WS than is included in WebLogic, for example. Let's take a look at how you would configure the filtering class loader. To configure the filtering class loader for an application, you must explicitly specify the packages that should be loaded from the application level class loaders. These can be from the library folders, or they can be from the shared Java EE libraries that you may be using. This is done in the WebLogic application XML file when deploying an EAR file, or in the WebLogic XML file when deploying a WAR file. You can see an example of this at the bottom of the slide here. This example is configuring the filtering class loader to load log4j and Antler packages from the application level class loaders, not the system class loader. The filtering class loader is also available for web applications. As of WebLogic 10.3.3, the WebLogic XML descriptor supports the same Prefer Application Packages XML element as the WebLogic Application XML descriptor for EAR files. Before version 10.3.3, we supported a configuration for Prefer WEB-INF classes, but this did not account for libraries packaged within a WAR file. So if you're using 10.3.3 or after, we would recommend that you use the Prefer Application Packages functionality as opposed to the Prefer WEB-INF classes functionality. So as an act of desperation in the past, I once unzipped all the jar files that I wanted to use in a WAR file and put all the classes into the WEB-INF classes directory and then enabled Prefer WEB-INF classes in order for WebLogic to use the classes that I wanted it to. So obviously this is less than optimal and somewhat of a hack. The filtering class loader for web applications allows you to use the jars that you want without having to do something like this. Next, I'd like to give you an overview of WebLogic's class loader analysis tool, and then we'll move on to the demo. As we discussed earlier in the presentation, libraries included in applications you're deploying to WebLogic can collide with different versions of the same libraries that are included in WebLogic. These problems can be hard to diagnose and resolve sometimes. As we explained before, we do offer the filtering class loader that enables applications to use their own libraries, or specify that they want to prefer the libraries embedded in the application itself. However, correctly configuring it can be a challenge, and up to 10.3.4 we did not provide any tooling for this configuration. The class loader analysis tool was introduced in 10.3.4 and really helps you solve these types of problems. It helps you identify class conflicts and resolve those quickly. The class loader analysis tool enables you to introspect the class loader hierarchy in WebLogic and look at specific classes or resources on a class loader and then analyze the Classpath conflicts. You could then use the tool to generate the corresponding filtering class loader configuration. This enables you to resolve the class conflict, which allows you to use the libraries that you want in your applications without conflicting with the libraries embedded in WebLogic. To go into a bit more detail, the class loader analysis tool allows you to analyze conflicts to see the different versions of a class that are being loaded with a different class loader configuration. By analyzing the class conflicts, you can determine how you want to configure the filtering class loader. Some conflicts are not an issue though. For example, if your application wants to use version 1.4.5 of a library, and the version included in WebLogic is 1.4.6, then the supposed conflict may not have any side effects. For example, the class loader analysis tool identifies several conflicts when Hudson is deployed, but Hudson works perfectly fine without configuring the filtering class loader. The purpose of the class loader analysis tool is to provide you with the information you need to decide how you want to configure the class loader in order to solve class loading problems. The class loader analysis tool will provide you with a list of packages and the corresponding XML for configuring the filtering class loader. You can take the XML, confirm that the packages are the ones that you want to filter, and then put the XML in the deployment descriptor in order to configure the filtering class loader. When you redeploy the application with a new deployment descriptor, you can take a look at the class loader analysis tool output again and see what the result of the configuration was that was just applied. Without this tool, identifying the classes that are causing a conflict, then pulling out the package name, and finally configuring the deployment descriptors can be a very painful process. This new tool greatly reduces the effort to perform the analysis and configure the deployment descriptor, which in turn makes it easier and faster to deploy open source software that packages many third-party libraries. Next, let's see a live demo of the WebLogic Class Loader Analysis tool. So let's take a look at the Class Loader Analysis tool. First, you can access it by adding ws-cat at the end of the admin URL for your domain. Then here we'll see on the left side the set of applications that you can run the Class Loader Analysis tool for. So I'm going to select Hudson.war, which is what I downloaded from the internet. And then I'm going to enable the detailed view, and we'll take a look at the conflicts that have been analyzed. Here we can see that there are several classes in conflict, and it lists the packages that are in conflict or contain those classes that are in conflict. If we scroll down, we'll see that here's where it provides the suggested solution. So it gives you the actual XML that you can copy and paste into your deployment descriptors in order to configure the filtering class loader for this specific application. Next, what I want to do is click on the Antler exception, and then we'll take a look at the conflict. So here we can see that the class file from the WebLogic side is coming from this jar file. And we can see here that this is the 2.7.7 runtime of Antler. And then it gives us a list of jar files from the application side where the same class is being loaded. So here we can see in the Antler 276 jar that it has the same class. And obviously, since this is 276 and this is 277, those classes could be in conflict. In this case, this is a benign conflict, so there's no reason why you would need to configure the filtering class loader for Hudson to work, but we're going to use it for this example just to show kind of the functionality here. We can also take a look at the class loader tree. We can look at the system class loaders. So here we'll obviously see that this system class loader is the one that's loading the WebLogic jar. And then we have our filtering class loader, but there's no filter enabled. And then we have a change-aware class loader that allows us to redeploy certain pieces of an application and recompile those and reintegrate those without having to deploy the entire application. And you can see all the class files that are included there, and this in and of itself is pretty handy. You can also choose to generate an XML report, and we'll take a look at this. So here you can use this for offline analysis. It tells you the class files that are in conflict. So we can see here in the WEB-INF, the Hudson original application, here are all the class files that are in conflict with the original WebLogic versions. And then it shows us the packages down here. So that's all for this demo and presentation. Thanks for your time. And you can find more information about WebLogic online on the Oracle Technology Network or one of the social network outlets below. Thanks.